We're going to take a look at lesson 3.4 on page 329 of your textbook. This lesson is titled, All Quantities Are Not Equal. We're going to learn about solving inequalities. We just finished solving equations. We're going to look and see if that same toolbox that we created for equations will also work for inequalities. Scrolling down towards the bottom of the page, they give us the motivation for this lesson. It says, remember the snow cone business from lesson 3.2? That was like 2 days ago. Of course we know it. 2 videos ago. In one of the questions in lesson 3.3, we found the number of snow cones they'd need to sell in order to make a profit of exactly $400. But it might make more sense to say we want to make a profit of at least $400. A statement that one quantity is more or less than another is called an inequality. The inequality 2 is less than 5 is a true statement because 2 is less than 5. The inequality x is greater than 3 is a statement that the variable quantity represented by x is more than 3. Just like equations, the solution to an inequality is the set of all numbers that make the inequality a true statement when substituted in for the variable. So number 1 asks us, give me a number that makes x is greater than 3 true. What's a value that's greater than 3? 4, 5, 200. There's lots of numbers at work. Unlike equations where we only had one solution, we now have lots of numbers that work as solutions. Give me a number for number 2 that makes x is greater than 3 false. So what is a value that is not greater than 3? 2, 0, -5. Of course, we could go on. One that people often forget about that makes this false is 3. 3 is not greater than 3, so that would also make this false. So be careful with that one. In many ways, solving inequalities is similar to solving equations. So here's the summary of what we did to solve equations. This is at the bottom of page 329. The first step was to multiply the same non-zero number or expression on both sides. The second tool we had was to divide both sides by the same number. Steps 3 and 4 were adding or subtracting. So when we built this toolbox in the last lesson, we decided that we can add, subtract, multiply, or divide an equation by the same non-zero value, and it doesn't change the truth value of the equation. So what we want to look at, this is the top of page 330, is do those tools work for solving inequalities as well? Remember, by work we mean it keeps the truth value. So we're starting with 10 is less than 20 in number 1. What happens if you add 8 to both sides? Is it still a true inequality? Let's see. Plus 8 plus 8. What is 10 plus 8? 18. What is 20 plus 8? 28. Is 18 less than 28? Yep, still good. So adding a positive number to both sides keeps the truth value. How about if we add a negative number? Let's add -8 to both sides of the inequality. What is 10 plus -8? Should be 2. 20 plus -8 is 12. Is 2 still less than 12? Yep. So far so good. I can add a positive number or a negative number to both sides of the inequality and not change the truth value. Let's see if subtraction still holds. Number 3 asks us to subtract 6 from both sides. What is 10 minus 6? Should be 4. 20 minus 6 should be 14. Is 4 less than 14? Yep. So far subtracting 6 from both sides keeps the truth value. How about subtracting -6? Be careful, we're going to have double negatives. 10 minus -6 and 20 minus -6. What happens when we have those double negatives? Double negatives will become positive. So I actually end up with 10 plus 6 and 20 plus 6. 10 plus 6 is 16. 20 plus 6 is 26. Is 16 less than 26? It is. So it works. So what we've just proven, we're going to put into this purple box, is that adding or subtracting both sides of an inequality by the same number does not change the direction of the comparison symbol. So does not. In other words, in my toolbox of tools for solving inequalities, I can add or subtract the same number from both sides of the inequality, and it does not change the truth value. This will let us solve inequalities. Just like in equations, I want to get my variable alone. So I put my wall in here. Helps me to work around the wall. I have x minus 5 is greater than 9. What is the opposite of minus 5? It should be plus 5. So I'm going to do plus 5 on both sides of this wall. So I have x is greater than 14. So now to graph that, I'm going to put an open circle on 14, and the values greater are to the right. This last note here describes the open and closed circle. If I have greater than or less than with no line under it, no equal part, that gives me an open circle on the graph. If I have greater than or equal to or less than or equal to, that gives me a closed circle on the graph. Values to the right are bigger, values to the left are smaller. Let's solve our next one. I have t plus 11 is less than or equal to 5. What is the opposite of adding 11? Subtracting 11. So I get that t is less than or equal to 5 minus 11 is -6. I am going to put a closed circle on -6 because it has the equal to part. And I want to be values smaller than -6, so I have to go to the left. You would check it by trying a value that's under your graph. So in this example, I could try 15 minus 5 is greater than 9, which works. In this one, I need something to the left of -6, so I could try something like -7 plus 11 is less than or equal to 5. That one works as well. So in building our toolbox, we've decided that we can add or subtract, just like we could for equations. Number 6 says write a verbal description of what the solution sets to the two inequalities in the colored box really tell us. So they do the first example. Any value of x greater than 14 will cause x minus 5 to be greater than 9. For the second one, any value less than or equal to -6 will cause t plus 11 to be less than or equal to 5. So just writing out verbally what we did in the purple box. All right, let's continue building our toolbox. I want to see if my multiplication and division tools hold for inequalities just like they did for equations. So number 7 says let's multiply both sides by 2. So times 2 times 2. 10 is less than 20 becomes 20 and 40. Is 20 still less than 40? The answer is yes, so this one holds. So far so good. I can multiply both sides by a positive number and it works. Let's see what happens when we multiply by a negative number. So multiply both sides by -2. We know 10 was less than 20. It becomes -20 and -40. Is -20 less than -40? Uh-oh, we have a problem. -20 is greater than -40. So when I multiply by a negative number, it changes my inequality. It flips it. If you struggle to compare negatives, think in terms of money or temperature. In this one, if I thought of money, would you rather owe me $20 or owe me $40? You would rather owe me 20, so that's the better or bigger situation. All right, so it looks like our multiplication rule is a little bit quirky. I can multiply by a positive and it stays the same, but when I multiply by a negative, I have to flip the inequality. Let's see what happens for division. Let's divide both sides by 5. $10 was less than 20. We know that was true. I end up getting 2 and 4. 2 is still less than 4, so that one still holds. Okay. So multiplying and dividing by a positive is okay. Let's see about dividing by a negative. Let's divide both sides by -5. $10 divided by -5 is -2. 20 divided by -5 is -4. Is -2 less than -4? Again, think in terms of that money. Would you rather owe me 2 or owe me 4? Uh-oh, you'd rather owe me 2, so I have to change the inequality. So it looks like with my toolbox, it works for multiplying and dividing positive numbers, but if I multiply or divide a negative number, I have to flip the sign of the inequality symbol. Top of page 332 puts this together for us in number 11. It says, if you multiply or divide both sides of an inequality by a positive number, the direction of the comparison symbol stays the same. So it stays same. If you multiply or divide by a negative number, the direction symbol changes or flips. So let's apply that to solve some inequalities. Get out my green marker. All right, so we have 4 inequalities here. In the first one, I have 2 times x is less than 10. How do I undo times? I divide. I divide both sides by 2, and I get that x is less than 5. No flipping needed because I didn't divide or multiply by a negative. This is going to be an open circle on 5. I want values to be smaller than 5. Smaller is to the left. In the one next to it, it says -3 times z is greater than or equal to 12. Again, I undo times by dividing, but this time I'm dividing by a -3, which should send up all those alarms in my head, where I say, okay, I know what that means. That means I have to flip the inequality sign. And then 12 divided by -3 is -4. It's going to be a closed circle on -4 because it has the line under it. I want values smaller, so I want to go to the left. Let's undo our division ones. I have 1/4 t is greater than -3. That's like taking t divided by 4. I would undo dividing by multiplying both sides by 4. T is greater than -3 times 4 is -12. I did not need to flip my inequality because my 4 that I multiplied both sides by was positive. I am going to do an open circle on -12. I want values that are bigger, so they go to the right. The last one is like taking b divided by -3. I would undo that by multiplying by -3. Again, those alarm bells go off in my head. I say, oh no, I'm doing something by a negative number. I need to flip the inequality. So b is greater than or equal to -6. Close circle on -6. I want to be bigger, so I have to go to the right. I can check each of these by trying a number in my solution set. So we'll do checking in purple. Something less than 5. Well, 4 is less than 5. Is 2 times 4 less than 10? 2 times 4 is 8. Yep, that works. In the second one, I need something smaller than -4, so let's try -5. Is -3 times -5 greater than or equal to 12? 15 is greater than 12. Yep, I'm good there. So it looks like my solutions are working. A value bigger than -12, I'm going to go with 0 because it's an easy one to use, is 1/4 times 0 greater than -3. 0 is greater than -3, so yes, it works. Let's try a 0 in this one, -1/3 times 0. I want to know if that's less than or equal to 2. I get 0 is less than or equal to 2, which works, so yep, it checks for everything. On the top of page 333, they bring this all together. So the steps involved in solving a longer linear inequality. Step 1 is simplify both sides of the inequality. If there's any parentheses, I'm going to distribute them out, and I'm going to collect like terms. Step 2 is to use tool 1, where we add and subtract to get the variable on one side, the number on the other. That one didn't have any weird stuff that happened. I can add and subtract whatever I like and keep the sign the same. Step 3 is where things get weird. That's my division step or my multiplication step. And I have to make sure if I multiply or divide by a negative, I flip the inequality sign. In the group work, you're going to get some more practice of solving inequalities and writing inequalities.